Okay, let's continue with the previous example and start analyzing that decision tree. And what we do in decision analysis is typically captured by the buzzword of backward induction. And what that means is that a good manager looks forward but reasons backwards. So if you take again a look at our decision tree, in which we need to decide, shall we explore, and then we might get a positive or negative result. Then we need to decide, shall we drill or not drill, and then again we can find oil or not find oil. So now let's illustrate what it means to look forward and reason backward. Look forward means that we map out the decision tree, but then what the best decision is, we have to reason backwards. So let's say we have a question, and the question is, if you receive a positive result, shall you drill or not drill? So that means that in our decision tree, we need to now take into account what happens at this decision node. So I'll just circle that again. So this is the decision node. So shall we drill or not drill after we receive a positive result? So what we need to do is we need to now calculate the expected payoff. So after we got a positive result, there is a 0.9 chance probability that we make 600,000. So what we actually do is we say, what is the expected payoff if you drill? I just call that expected payoff, drill, given positive result. Well, there's a 0.9 chance that we get 600,000. And there is a 0.1 chance, and of course after each chance node, the probabilities need to sum up to 1. Nothing can be left over, or nothing can be more than 1. So if we get a positive result and we drill, there's a 0.9 chance that we get 600,000, and plus a 0.1 chance that we lose 250,000. Okay, and if we sum that up, I have also summarized it here. The expected payoff would be 515,000. Okay, so if we want to, we can take here a little note and just say the expected payoff of drill, I don't know if I can, EP equals 515K. So that is the expected payoff if we drill after we get a positive result. So what is the expected payoff if we do not drill after a positive result? And then we would have to calculate expected payoff and D not drill given a positive result. Maybe I should do it like this again. Not drill given positive result. So then we just lose 200,000. There's really no probability involved. Okay, so because the expected payoff of 515,000 K is better than a loss of 200,000, so we can already say that we delete that this is not a realistic option, because the expected payoff from continuing after a positive result and to drill gives us an expected payoff of 515,000 K, which is much better than 200,000. loss. So therefore we can eliminate that decision through backward induction. So the decision is we drill after we got a positive result, and we eliminate do not drill. Let's move to the next question. If you receive a negative result, okay, then shall we drill or not drill? So now we are focusing on this decision node. So if you get a negative result and we drill, then the expected payoff of drill given an R negative result is we get only with a probability of 0.05, we get the 600,000, and with a probability of 95 plus, with a probability of 95%, we make this huge loss of 250,000. Okay, so that means the expected payoff from drill, or the expected value of drilling after we get a negative result, is negative 207,500 if we do the math. Okay, so we can put here the expected payoff would be negative 207.5K, which is of course a greater damage than just leaving it. So that means if we get a negative result, then through backward induction, the best decision is to eliminate the drilling, because that will have a higher expected damage than just calling it quits. Okay, so let's move to the final decision in this example. So, shall you explore or abandon? And you can see that I have already made the eliminated decisions, which is do not drill after a positive result and drill as a negative result. They are eliminated, so we don't have to worry about these. So now we just compare the expected payoff that we get from exploration. So what is that expected payoff from exploration? Or the expected value? Just call it E. Okay. So now we focus on this decision node. So now we get with a probability of 0.4. If we get a positive result, we drill, and if you remember, we calculated an expected value of 515,000 plus with a probability of 0.6, well, we got to get the 200,000, which was still better than the loss of 207,500. So minus 200,000. Well, if you do the math, which is also here in that yellow box, the expected payoff or expected value from exploration is 86,000. And of course 86,000, the expected payoff or value is 86K, which is greater than the 0 from abandoning it. So the decision is clear, we should explore, and if we get the positive result, then we drill, and if we get the negative result, we do not drill. So now we have derived the optimum decision through backward induction. Okay, let's just stop here and then continue in the next video with the concept of sensitivity analysis.